Hello, and welcome to another how-to video. I promised in a previous video going over SolidWorks electrical stuff that I would do a future video. Hi, welcome to this one, where I go over how to create new symbols for us to use. Quite a common thing. A lot of times the stuff that we sort of import from the manufacturers isn't adequate for what we're looking for, or a lot of times we want some, especially I find it useful for, say, I/O cards. A lot of times the I/O cards that sort of come in, if they come in at all from the manufacturer, don't really sort of meet the standards and the techniques and things that I want to use to wire it. So I'm going to focus on that, the creation of a symbol for an I/O card, and knowing that those sort of techniques we can use to create basically any symbol we want, and it just really depends on what we need at the time. So let us jump right in, and actually to get started, we're not going to actually start in SolidWorks Electrical, but rather on Alan Bradley's website, because I've grabbed a couple of I/O modules that I want to create, namely the 5069 IB16 and OB16. These are sort of the main I/O modules, the 24 volt DC I/O modules for the 5069, the new family Compact Logix PLCs. So I'm here on their website, and I'm gonna take advantage now. You do not need an account for this portion of their website. In fact, I have an account for Rockwell, but I'm not logged into it. You can get to their sort of documentation, most of that stuff without. It says you kind of need it, but I literally just download it and I'm just logged in. If I move my little Zoom recording window, I'm just user. I'm not even logged in. So what I want to look for to start, what we need to start really is something that tells us electrically, like what these different connection points do. Because for a schematic symbol, that's really all we need are what are the connection points, preferably what are the order they're in, so that we can put them in the right order. And usually that is this technical data. The user manual doesn't have really the wiring in it. And I've already had it open once shortly before the video just to make sure I had the right manual. Full disclosure, right? But this is kind of cool where it has like physical layout. They do require clearance space, so when we lay out a cabinet, that'll be a thing we take into account, the same information from this manual. But this is sort of the important bit, that this is what we need right here. You know, we need that, but we need that. Notice this is for the IA16, and this has got all of this family's IO cards in it, basically. But we need to find the IB16, and that is right here. So really, this picture is all I'm looking for. And we've got, what do we got? Basically 16 pins, 2 aren't used. So we've got 18 pins. Now in the symbol, we really don't need to use those last 2, or create those last 2, I should say. So this is what we want. I just really wanted to see, sometimes on some of these IO modules, there'll be like a DC or just a DC power like in the middle, or a common in the middle, right? And I wanted to know that. I didn't know that ahead of time. I needed this diagram to make sure I was creating my symbol correctly. So our symbol is basically just going to be 16 PLC inputs. Pretty simple. So when it comes to inputs, we want to sort of draw the symbol the way that Alan Bradley has here, in a way, as far as orientation. So when it comes to SolidWorks Electrical and our schematics, we're going to draw input card symbols so that the inputs come in from the left, right? The card itself will be on the right side of the column of our drawing. When it comes to outputs, we're going to want to draw the opposite way. And actually, if I scroll further down, I should get to the output cards eventually. OB8, that's an 8 point. I want a 16 point. So they actually draw it backwards from what I'm talking about. They feed both from the left. Output cards in our schematic style, we tend to want to put the card on the left and the outputs that it's powering to the right. And I'll show that when we actually, draw the schematic here in a second. So, and that's actually, they're both pretty. Now this one, this is sort of key. This is the output card we're going to create this symbol for. This one does use those last 2 pins for power. And actually, if I look, LA Power, sometimes we do need to be careful. We need to pay attention. Sometimes, even though they show a DC power supply here, sometimes it's actually receiving power from the PLC bus. And if we look, this is labeled LA minus. I don't know what LA stands for. Somewhere in here it would define that. But this is LA minus, this common point here for these solenoids, as well as LA minus here. So no matter what we do, we need to remember that these two power supplies, if they are separate, need to be bonded together. That's kind of important. These are the same. These are common points. So yeah, so we'll stick with this. I'll leave this up for reference. Do the input module first because that one is sort of simpler. I'm back here on the drawing that I've sort of, or the sheet set rather, that I've sort of been working with for the other videos, and I'm going to go ahead and create a new sheet. And again, we want to kind of live in schemes. Schemes are our wiring diagrams, and here we go. We've got a blank scheme, scheme 6, and I'm going to head up to library, and the first thing I'm going to do is actually go to manufacturer part management. I'm going to create a manufacturer part for these cards, and I'm going to expand the PLC category down here. Go to I/O modules. I like to keep things in the categories where they belong. We don't have to do that. It makes it a lot easier to find later. So we're in digital I/O, but specifically digital inputs. And no, we don't have any because I didn't import Alan Bradley's that library in the previous video. So I don't have anything here now. So I'm going to go ahead and add a manufacturer part. The reference can be just the part number. So this is going to be a 5069. IB, we're in the inputs, right? Yes, IB 16 is the first one we're on. Manufacturer. Now, Alan Bradley already does exist because we have imported it before. There's a whole bunch of manufacturers here. So unless you truly have a new manufacturer that isn't in this list, like I can just type, but it's best to just pick it from the list. Otherwise, it will create a new manufacturer. Library, frankly, doesn't matter much. I like to drop them, everything I create in the user library, because later, if I have to move computers, it can be backed up. It can be zipped and taken to a new computer. I am going to change it because this is not a PLC. I am going to change it to a module without interface. Now, frankly, that doesn't matter at all. I'm going to be frank, that doesn't matter. It's just another way to sort of organize things, a deeper level of organization. I'm going to pop back over to the manual and see what do they actually call it for the description. So I want to pop up to the IB16. That's this. Syncing and digital, 16-point syncing input. And it's simple. So the K, if I remember right, the K is high speed and the F is conformally coded. Conformally coded is where sort of the circuit board inside has a silicone-ish material over it to help with like sort of explosion-proof stuff. Now, we do not have any of this stuff yet. We will come back and associate line diagrams, schemes, at least, and 2D footprint. The 3D part I don't worry about so much. It's good to put that in there. I truly don't worry about it much. Width, height, and depth, we can get that from the manual. Probably not this one. I don't see, this is all electrical specs, it looks like. We can get this from the manual, a manual anyway, not this one. And we do need to define this eventually. Eventually we will define this stuff. But it is better, rather than take it from a manual, it is better to take it directly off of Alan Bradley's 2D CAD drawing and take measurements ourselves. Because when we go to do the panel layout, it will use this information to scale the component, the drawing that we drop in. It will scale it automatically to our sheet scale based on this information. And the reason it's better to use the CAD model is Allen Bradley and other manufacturers as well, it's not just their fault, they tend to ignore things like locking tabs. that might add a couple of millimeters if you think about. So this is a bounding box of the whole part, just a box that encompasses the whole part. They dimension like the bulk, the main width. But if there's a locking tab, say, that sticks out a few millimeters, that is included in this bounding box that we're defining. However, it's excluded from like their officially published width. It's not a huge deal, but it'll throw off our scale in our panel a little bit, and I like to be complete that way. So I'm going to ignore this for now. I will come back and finish that. And then here under manufacturer data, we've got card position, we've got slot. This is sort of how the built-in SolidWorks Electrical PLC manager thinks about these cards. So card position, it doesn't really matter. Slot is how many slots does this card take up? If we had a PLC rack, and in Siemens, Allen Bradley, several, there are chassis-based PLCs where we buy a rack with a certain number of slots in it. Some cards take up more than one slot. That's where this is defined. This card, even though we're not using a rack with predefined number, this card takes up one slot, so I'm going to put that in there. So later on, when we bring it into a PLC, we have the one slot thing defined. User data, I don't believe there's anything here we need to play with. You can, again, this is all database stuff. It's more stuff that we can define. If you find it useful, go ahead and populate it. It's variables that we can pull out later. And then circuits are important, right? Circuits are important. Circuits are going to define basically where we can connect things. And the important part, the main important part is whatever we do here, and we do need circuits here, whatever we do here has to match the drawing, the symbol drawing we're about to create. You just bear that in mind, that whatever you do here has to match the symbol. So we can do this a couple of ways. So one, I can add multiple. I can add, and we changed the circuit type here, right? Circuit type black box. That I mostly use for weird devices, things that we don't need a lot of detail on, and frankly, may not know what it is. But it's best, I find, to set we've got a bunch of circuit types here we can select, and there's even more. You can click more to get a bigger list. But for now, I mean, I find it best to just set it to what it is. We got digital inputs, right? Digital PLC inputs. We only have one terminal per circuit, one connection point per. But we've got 16 circuits. 16, oops, why aren't you letting me type? Oh, numlock, my computer rebooted, and numlock turns off every time for frustrating reasons. But there we go. So we're going to add 16 digital inputs, one terminal per. I'm going to hit OK, and now I've got them, right? They're here in the list. These are the circuits I'm going to play with. Each one has a terminal. If I keep clicking now, it doesn't change, obviously, because I haven't entered anything in. But if I select number 0 here, right, the mark, if I go back to the book, so it's input 0, but 0, 0, I0, 0, rather. I was too far away from my screen to see the I. I0, 0 is sort of the mark that you'll see on the PLC here. So that's probably what we want to use for the mark. The mark is the label that'll show up on the drawing. And I'm going to use I00, and I'm also going to copy the I0, so just so I don't have to keep doing it, right? Notice under terminal marks now, I00 shows up. And I can go down, I have to go down for each one of these and do the same thing, of course, going up by 1. Now, the mark can literally be anything you type in here, but when we put the symbol in a drawing, that is what is going to sort of auto-populate on our symbol. So we're going to use a variable when we draw it, and that is going to be automatically pulled in. So we're just copy and paste. Riveting content here. Riveting content. And we go through. Now I'm going to create here in just a second. I'll show another way that this can be done. And it is strictly a matter of preference. And I mix and match. We don't need the 0 for number 10. We just need the I. I mix and match methods. This multi-circuit method I do a lot. And it really depends on And actually, I could have copied the 1, can't I? So save myself. Save myself. I mean, you end up doing a lot of same-ish typing in this software, which is okay because, I mean, once I do this, this thing is here. I can never touch this again. If I get it all set up correctly the first time, I mean, it's here forever, so I can use it for years without ever touching it. So we got all our I/O in now. I'm going to add one more circuit, and then I'm going to delete it because I don't need it, but I'm going to add it just to show. Um, so we got a black box. I'm going to leave it as a black box for now, I think. But we can add, if we wanted to, we could put literally one PLC input circuit here and just add connection points. Right? All of these in this list are the places where we could put wires. So I could do my I01 here, I02 here. And really the only difference from a practical standpoint that this makes is how now we go create the symbol, the 2D symbol. It matters because yeah, now when we jump into the symbol, it'll be kind of obvious. It'll be kind of obvious how that works. But so either way works. I'm going to go ahead and delete that circuit since I don't need it. We got all our things here. User data, just double check quick. We're going to come back and populate this stuff. So we did 16 digital PLC inputs. That's the thing to remember. So click OK there. We now have the part number. It's in the database. Again, get rid of my little zoom window. I don't know why that's so intrusive this time. All right, so for now, I'm done in the manufacturer part. I'm going to get rid of it. Now I'm going to go into symbol management, and I'm going to go to the same place, PLCs, I/O modules, digital inputs. Now there are some in here by default. I'm not too nuts about the defaults. I'm just not. So I am just going to right click, create a new one. Okay. It has a title. And honestly, the digital input, the 16-point digital input that we just created, we can use for any I/O card that has 16 points. So I don't recommend this title actually be the part number, the 5069. I mean, I suppose it could be, but it's better 16 point because this symbol can be used for multiple part numbers. So it's best to be kind of generic here and think ahead. What else could this be used for? And really, it just has 16-point digital PLC inputs, right? So I can use it for anything in the future. 16, let's see, card with 16 digital PLC inputs. I can use it for anything. It doesn't necessarily have to be the part number I'm working on right now. Again, library, I like to throw stuff in user. Later on, again, if I migrate, I can back it up. Now, if this symbol were very specific to just that input card, we could define the manufacturer and the part number right here, and then they would be always tied together. But because we're keeping it kind of generic, we really don't want to do that. We don't want to tie a manufacturer in here. We will go back to the manufacturer part and tie the symbol to it. That's fine. But this isn't specific. This symbol is not going to be specific to the one part. So the rest of this, we do want cross references. Probably, well, let's do same level. Different cross reference types give us different things. Now the cross references won't actually show up unless we tell them to in the symbol. So it's okay to set it here even if you don't want them. You just don't put them in the symbol. But click OK, and I'll be met with a blank part here that I can double click, and I'm now in a DWG. This is a two-dimensional, effectively AutoCAD formatted drawing. Okay, so I have up here in the draw all the standard stuff. If I zoom out a little, this is the origin. This point right here is 0, 0. I can get my mouse kind of close, and you can see that down at the bottom of my window, the coordinates. And we're gonna basically draw. Now we need to draw effectively the shape that we want to put in our drawing. And I will be completely honest, over the years I have not entirely figured out the unit system that these drawings use inside SolidWorks Electrical. I believe it's metric. I will tell you though that it doesn't really matter because I've sort of discovered a trick that works. Everything we do, we just forget about units. We're just going to talk about unitless numbers when we draw this thing. We are going to use dimensions, but no units. Um, when we draw this thing, multiples of 2.5 seem to work very well. And if we stick with that, so 2.5, 5, 7.5, 10, that kind of thing, that lines up basically with this dot grid spacing on our scheme so that all of our wire snaps will work correctly when we go to throw it in here. It's a neat trick to remember. So stick with multiples of 2.5. And I have found, so I'm gonna let's start at the beginning and grab a line. So the output card is going to be fairly simple. It's just going to be a rectangle with connection points on it and some labels, right? So we get a pop-up. I can either start drawing and it'll snap to 0, 0. That's fine. I like to use the input over here on the left and actually type 0, comma 0. That enter now in my line. Notice it starts now at 0. No questions. I like to sort of draw down. So in AutoCAD, this actually takes AutoCAD input as well, this field. So now the 0, 0 I just typed, the 0, 0 that I just typed, it was the start of the line I'm drawing. Now it wants to know where to go, right? Where is the next point of the line? That next point is going to be 0, comma, minus 10. Okay, enter. And now I'm going to zoom in a little just to make it bigger. I've got a 10 unit long line here, right? Now, there's a problem. I can't just keep doing that 0, comma, minus 10 because that's absolute. Whoops. Must have hit a shift. 0, comma, minus 10 is absolute. So if I do that, I didn't get anything because I was already there. I was already at that point. What I need to do, one of the key commands in AutoCAD are relative coordinates. So start the line at 0, 0 again. The first one I can go 0, minus 10, right? 10 units long. Relative coordinates start with an at. So for instance, if I just typed in, let's say 2, comma 2, just so we have something in there, right? That's the line it just created. Okay. Let me delete that. If I use relative coordinates that start with an at 2, comma 2, instead of going to 2, 2, it's going to move 2, 2 from where it is. So at 2, 2, notice that's a way different line than what I just got. So at our relative coordinates, that is important to remember. Line, drop it on the bottom here, and then at 0, comma, minus 10. And I'm going to copy this because I can just paste this in. So I can hit enter and just paste. And basically, the reason I'm doing this is I have a snap. I'll just grab a line here so it'll snap to something. Every end of these lines now is a snap to. So that when I come over here to edit symbol and start adding circuits to it, it'll snap right to those points at the right spacing to line up with my grid on the drawing. Kind of a neat trick. So draw back to the lines. And honestly, right now, I don't actually count because you can always delete. I don't actually count how many I'm creating. I just know I got to get to 16 eventually. So I just, Control V, enter, and just keep dropping lines in. A bunch of them. I'm probably there, but I'm just going to keep going. Probably enough. I truly didn't count. So now we got a bunch of lines in, and the reason we did it that way, we could have just drawn a rectangle. The reason I did it that way was so that I had those ends of the lines so I could snap things to them. I want to now edit my symbol. I need to create circuits. This is a list of the circuits in this symbol, and there aren't any. So I'm going to create a new circuit. I need to create 16 of them. And remember, this has to match. I need digital PLC inputs. Digital PLC inputs. All right. 16 of them. And now I've got 16 circuits, 0 through 15 that popped in here. Now I need to select the first one and a connection point, and that's going to open this up, right, to let me drop a connection point in. Now, this doesn't auto-rotate. I can use the space bar just like in a scheme outside to rotate that point. I want the notice that there's sort of a little circle at my cursor and a big circle out. I want the big circle basically pointing in the direction the wire will be coming from. So on an input this direction, and if I space an output card, like I said, I want it this way going to the right. But input's this way, and I'm going to snap it 0, 0 and just drop it there. So this gray text and this circle, the gray won't show up on our drawing. That's just showing SolidWorks where the connection is. The black absolutely will show up, and that is going to be the text that, when we created the part, entered in the mark field. Okay, so I will get to that in just a second because we can sort of edit those all at the same time and move them and align them, make things pretty all at the same time. So, but one thing we need to make sure of is every time when you do the 16 circuit method, every time we need to move and select the next circuit. So connection point, I don't have to rotate it again because it's already rotated. Go to the end of the next line, right, and drop it in. If I don't select circuit 2 now and drop a connection point in, I now have 2 connection points associated with circuit 1. That won't work because that's not the way we created our part. We need to remember, and that's, I forget it all the time, when you're adding connection points, make sure you're on the right circuit. If you have more than one connection point per circuit, that's fine, but we don't. So we need to make sure every time to click to the next circuit and just go down the list and start adding, and even there I'm not sure. See, just go down and start adding. Now we'd also need to watch out because each one of these line segments, it's going to be hard to hit with the way my snap settings are. Each one of these line segments also has a snap point in the middle. That'll show up as a triangle under your cursor. Like I can't even zoom in, the box doesn't get any bigger. Right now it's a square. If you're in the middle of a line, it'll be a triangle, and just make sure you're at the right point. I mean, there are reasons that you might want to be in the middle, that's fine, but whoops, undo. See, I spoke too soon and snapped to the wrong point. So we're just going down the list, and honestly, this is sort of the only technical part of creating a symbol, is making sure that one, we're getting the connection points in the right circuits and that everything matches the part that we plan to use. Hey, look at that. I ended exactly where I needed to. Awesome. So now, these are, and I'm going to leave these lines in here because the lines here that I drew are going to form the left edge of the symbol we're about to drop in a drawing. So those stay. Like, those are done. I'm going to not move this text yet. I will, but I want to finish basically the rectangle that makes up this part. So I'm going to grab another line. I'm going to start at 0, 0, and basically add a little bit going up. I don't need the full 10. I usually just go up by like 0, comma, I mean even 5, but I'm going to go 2.5 this time. See, now I've got a little buffer. So my first input point starts a little bit below where the rectangle will be. And I'm going to do the same thing exactly at the bottom, except remember, negative, right? 0, comma, negative 2.5. Oops. Oh, and I screwed it up. Remember relative coordinates. Get out of there. Line. Relative. At 0, comma, negative 2.5. There we go. And then, I mean, it's really just a matter of closing in the box. So we're sort of done. And we can hold, I have to remember, down here at the bottom, we'll turn off your snap. And for a minute, I think I want snap off. I don't want to snap to the grid. I want to snap to a line. From here, I'm going to go at, and I'm going to make it 10 wide. At 10, 0, right? We're 10 wide now. We don't need a lot of width because these labels are fairly short. Plus, honestly, I'm going to shrink the text, I think. I don't know for sure yet. We'll see, but I think I'm going to shrink the text. So up here too, we're going to go at 10, 0 to get over there. Oops, extra key press. There we go. And then literally the backside, there's nothing going on. We can just connect those 2 lines. So now this is the symbol we're going to drop in. It's a rectangle, right, with point labels. Now, that would be good, but if you remember when we dropped in our circuit breaker, where is it? We had a label here for what circuit breaker it is. We also had the part number. And that is stuff that we need to drop in when we create the symbol. So that is over here under attributes. And notice every one of the attributes are basically variables. Every one of these p tags is a variable, and p tag specifically is the mark that we associated with that circuit. So the I00, the I01. But right now the symbol doesn't know that, so it's a variable, right? And then whatever part number we use with this symbol in the future can use those variables and populate them. But we can right click on attributes and insert, and we'll get a list of all kinds of stuff we have. The CB502 thing, that's a tag, right? That's what we want. We need the tag. That'll be, I mean, for instance, PLCIO1, whatever we name it when we get it in, that's it. We need the tag. I also like to pull in the manufacturer and the reference, right? The manufacturer and the reference. And I got to be honest, I switched at some point from so manufacturer base, reference base, all. I switched at some point, and I honestly, it's been so long, I don't remember which one I switched to. When we do this as a PLC, we are going to sort of associate the PLC and all of its I/O cards into what SolidWorks calls a parent part. The PLC will be a parent, and it will have I/O cards as children. And I forget, and one of these, if we use the base, I think the base will only pull the parent PLC part number. So I think we want all in order to get the part number of the actual card. Or is it current? Current is new. Actually, current is new over the last revision of this I use. Let's start out with current. I mean, we don't have much to lose. We can always edit later. We can change these and do an update, and it doesn't really hurt anything. I'm trying to think if there's anything else that I usually also like the description. Um, so where's the description going to be? Not here, not under manufactured data. We don't need any of that stuff. There should be a user data from component description. I like to throw that in there as well. More information we can give somebody using our drawings, the better, right? And then the very last thing is the cross-reference. This, like I said, it doesn't matter when we created this symbol, if we turned on cross-references, because they won't show up unless we include the cross-reference attribute. So we're going to click OK. We're going to get a big lump of text, right? Those are all the variables. And again, these will be replaced with the actual values once we get it into a schematic. So now it is time to just start moving the text around to where we want it. So I'm going to sort of zoom out, and I need to be very careful. If I select, basically this pound sign out, I get the text. But if I'm too close, I'll also get the gray. I don't want the gray. That's a thing to note. So I need to be close, but not too close. So all right, so I got the bottom. I didn't get any of the gray. I'm going to do the same thing with sort of 9 through 0 here. Grab them. Oop, I needed to hit shift to select them all. Don't forget to hit shift. So shift and select the control and select the rest. Why didn't shift work? Control and select the rest. There we go. Live video. Um, and then we need to properties, and that'll give us alignment, or it should at least. Why are you hidden? It should give us alignment. Text alignment. Is it here? They moved it. It's in a different tab. There we go. Beautiful. Justification. We don't want justification to be top right. I don't want the height to be. I want to shrink the text, because in the scheme of things, we don't need the label to be that big. So I'm going to shrink the text and say hello to the office dogs. Everybody should have an office dog. Ooh, that's kind of ugly. That's kind of ugly. Do we need to Huh. Do we need to do them individually? We used to be able to do them all as a lump. We used to be able to do them all as a lump. But why are you not letting me do that now? So was I again in the wrong? I must have been in the wrong field again. Or it is possible that I had one of the gray things selected and didn't know it. That's possible too. I'd have to go back and watch the video to remember. So here we are. You should now, there we go. I want to align it, uh, trying to think, middle left, um, because then I can sort of grab the alignment here and move it. Now I want some offset. If I put it, I have found over the years, if I put it right on the line like it is, there's not a lot of gap, and the I, right, in I00 will sort of hit the line. But if you give it a little gap and sort of line it up with this circle, and it's a manual thing, but give it a little bit of a gap, right? And because I had them all selected, they all moved. They should all be aligned. They're not. That's frustrating. Why didn't they all move? They should have all moved. Ooh, redo. Don't want to undo what I just did. So why didn't you all move? That's disheartening. I mean, the other option, of course, is always maybe I remember again things you don't do. Uh, Things you don't do all that often. So I'm going to reselect everybody, which is actually if I undo, it's easier to reselect them way out here. Um, let's select everybody and control select everybody and a couple more, maybe one more, whatever to get them all. Okay, do I have something selected? I shouldn't because I don't have the same properties now here. Okay, let's go middle left, right? I grabbed the dot. If you grab the dot, it's going to move only one. If I grab this, now admittedly, moving the dot's kind of easier because you have something to line up with. Here, you're just kind of visualizing it. I want the dot centered, like I said, but if you grab the dot, it only moves the one. You actually have to grab the text. If you grab the text, if I zoom into some random one, see they all moved now, and they're all fairly aligned. I'm now going to shrink them. I don't remember what I used. I think one was good for this particular setup. I think I think I leave sort of this alone. So these two, so cross references, let's do that one first because cross references is the oddball. The cross reference I don't want up here. I usually put it down here. This is the only one that's sort of an oddball. I put it down here. I do shrink it so that it's smaller, right? And then if we have a cross reference to this part, it'll show up down here in the corner. The rest of this stuff is going to stick together, except not in this order. I like this order. Sort of tag. This would be the manufacturer, so it'll say tag. It'll say, you know, IO card 1, whatever number we give it. Allen Bradley, 5069 IB16, and then a description that we can give it that we haven't yet. Right? I like that order. I want those centered at the bottom. And then I'm just going to, sort of align. And this is really a guessing game, right? This is really because I want the blue dot aligned with the center, but there's no real way to force it to be perfectly aligned. It's a bit of a guess. It just is. Also, I like to shrink down a little bit these guys. Let's shrink those. They're at 2. Let's go 1.5. So the tag is the prominent piece of information we're trying to convey here. The rest is really just supplement. And then, kind of just, there might be a better way. I don't know it. Kind of just click between one that I have, I know this is good. If I come up, we're pretty close, it looks like, anyway. And then the tag sits on top. And let's see if we're kind of guess based on where your cursor's at. We're kind of close. That'll probably look okay. Now, crucial, again, we're in a symbol editor. I mentioned this in a previous video. Crucial. Control S, save it. Okay. And then I can close because that's really all there is to creating a symbol. Remember, you have to put the information in, right? Terminal labels will come in as attributes on their own. The additional information you have to add, and remember, we're basically drawing the shape of what we're going to drop in the drawing. So I've already saved it. Let's close out. I might as well save it again. I didn't change anything but clicked. All right. Uh, Now, before I go on, I'm going to go to back to my manufacturer part manager and into the PLC section. Now, the cool part, you can drill all the way in, but you don't have to. After you've created the part and put it in the digital inputs, it'll show up like it's here at the PLC level. 56, there it is, right? It shows up. You need to drill in to create. You do not necessarily need to drill in to find, which is, handy. But I'm going to open that up now and go back to the data scheme. We now have a scheme. This part is going to be associated with a card with 16 digital inputs. That's it. So 16-point digital PLC inputs. It's now associated with that scheme. I'm going to hit OK. Okay. Um, and at this point, I'm going to go ahead and drop in. I've created a sheet just for this, really. So schematic, symbol, other, and come down to the PLC digital inputs. Let's go to I/O modules. There we go. Right, here's our card. I'm going to drop it in. N is sort of a default PLC number it uses. Doesn't really matter. We need to associate a manufacturer part. Just like before, we're going to search. And again, this is where I was mentioning in a previous video. This is not a base part. I created it as a module, I think, without interface, right? So class and type can really screw up a search in this window. You can just go to all and find it based on part number, and that might be easier as your database gets bigger, right? That can be a hang up if you don't remember it. So we'll select. Notice everybody's green because it matched, right? We made sure that the symbol we created matched the circuits in the part. Everybody's green. So if we hit OK, now we have data that populated up here, right? It populated all of our I/O labels. The I/O labels are spaced nice and far apart so that we've got room to get the actual components in that are going to be the inputs. We don't have a description. That would come from, if I right click and go to symbol properties, that description comes from here. So I can call this main, let's say, main PLC input slot 1, something like that, right? That's where that comes from. It is this description that we added to the symbol is a description of just this part of the symbol, not necessarily the manufacturer part or the even the other stuff that we created. There is one other part of this sort of creation of a new part so we've created the manufacturer part. That's a biggie. We've created a symbol for it. And also in this case, it's a symbol that we can use for basically any 16-point card. Input card. Outputs, like I said, I like outputs on the other side. I'm going to skip that for this video. I think I went into enough detail. It's the exact same process. The literal only difference when I make an output card is this box is going to go this way. Like I drew it to 10, 0. I would go minus 10, 0, right? The box faces the other way. That's literally the only difference when I make an output card. Oh, also, it's got the 2 power supplies, so 2 more pins. Um, 2 more pins. And actually, we probably could have gone with 5, made this shorter, because I spaced these 10 apart. Probably could go in and edit, and you can edit this symbol at any time. Like if I wanted to make it 5 apart, symbol, open, because I do kind of think I like that at 5 apart. Let's move it, and will you let me, hold on, undo. I'm leery of grabbing the pink. We've already seen what happened. There we go. Then we got to move. Oops. Then we got to move that too. Ooh. Can I get both? Will you let me? Nope. It's only going to let me because the line. So this line's 10. Notice I could snap to the middle, save a little bit of time here. And if I'm just going to do the 1 for now. But if I save that, we could save some height on our drawing. I'm going to go to symbol now. If you do a change, you do have to update. Notice it got closer together. 5 might be a little close, but notice the 2.5 thing, if I zoom in, you see sort of the dots on my snap grid. The 2.5 thing lines up with those snap dots. So, when I draw wires, things line up correctly, right, to the grid. So that's why when you're creating symbols, remember 2.5, multiples of 2.5. I have a suspicion that has to do with the 2.5 centimeters per inch, 2.54 centimeters per inch thing metric to standard conversion, I think. But I haven't been able to confirm that. So there is one other thing I want to cram into this video, this treasure trove of symbol creation, and that is the 2D footprint. Because effectively, if we look at our library and our manufacturer part manager, we are pretty much complete. The only other thing, I mean, a line diagram, yeah, you know what? On the fly, I have determined to break that into a separate video. We will do line diagrams and we will do 2D footprints in a separate video. Both are very important. Um, both are very important, but we will complete this particular part in a second video. So with that, the dogs are saying goodbye. The dogs are saying we need to go out. I'm going to sign off here. Hopefully this was useful. And I mean, at least mildly entertaining for watching me draw a bunch of lines and put dots on the screen. I would like to thank you for watching, and I look forward to seeing you in another video.